Okay, video number 4. Hopefully this addresses page 4. So oftentimes you'll see the fundamental theorem of calculus written in Leibniz notation, which is a little cleaner. You just don't have to write as many functions, but we can just basically say if we try to take the derivative of an accumulator function, we just get the function we're trying to integrate, which is pretty much what it was saying before. It's just cleaner. You don't have to define the function as g first, and you just get to use fewer letters. The Leibniz notation actually works through this thing pretty quickly. So here's what the first fundamental theorem of calculus is basically telling us. Suppose we want to take the derivative of some accumulator function from 4 to x of this function t ln t dt. It's just basically saying that if you try to take the derivative of this thing, you just get back the function you're trying to integrate, only now it's a function of x instead of being a function of t. So this is just x ln x. Boom, done. That's it. That's the whole thing. Finished. This one's a little weirder because the upper limit in play here is x squared. So just like if you sort of know that d dx of sine of x is cosine of x, because you know that rule, d dx of sine of x squared isn't just cosine of x squared, because this is a function that needs the chain rule. So you're going to go back inside and pick up an extra 2x. This is pretty much the exact same thing. According to the FTC, if we try to take the derivative of this type of weird accumulator function, we're just going to get this as a function of this upper value here. We should get tan of x squared. But wait, there's more. Now we pop back inside to gain an extra 2x. So I would say the answer to this thing is 2x tan of x squared. This one, we're kind of still doing the chain rule too. If you want, you can act like it's a chain rule problem, that it's this function, now a function of x, back inside for a times 1. But that doesn't really do anything. So some people like to write, you might see the FTC written in this weirder, slightly different way to plan for the chain rule, that if you integrate some function a to some g of x up here, then we know that this is going to be equal to f of g of x times g prime. That you're always doing the chain rule, that the chain rule is always in play. So kind of weird, and how is this useful? Sort of, we're getting there. The FTC 2 is kind of going to be a big deal, but this is FTC 1 in play, and in the next videos we're going to look at some old AP questions as these accumulator functions, and doing FTC 1 is a big theme on some of the AP free response questions. That's end of video number 3.